I'm Dan DeMers. I'm the CEO and co-founder of Cinchy, and I'm very excited to talk to you today about the emergence of data collaboration technology and how it represents the beginning of the end of applications. Quick intro on myself. So I'm Dan. I spent just north of a decade working in a number of big global banks in IT, building enterprise systems. Most of that was what was the largest financial institution in the world. In capital markets, building everything from front office trading platforms to back office stock record systems. So they're very complicated systems, very global in nature. And through that experience, I met my co-founder, Karan, and that's where we recognized a massive opportunity to really simplify the entire process of really how organizations build and deploy technology solutions. So that's really what we're all about, and we see this as a massive opportunity. What I'd also say, actually, before I get into it, is that mic is live. So as we're talking through, please feel free to jump in with a question. The more interactive, the better. If there's too many questions, then we'll put a halt until the end. But let's give it a go and see how that works out. But through that experience, working in these big global banks, what we observed is that new technology often adds exciting new capabilities, but it also adds complexity. And that, if you think about that, technology adds, it doesn't subtract, it doesn't take away. So what's happening is this is not a sustainable model. That complexity can't continue to grow indefinitely. So what we really need to do is think differently about how we evaluate new technology and reframe to think about it as what does it remove, how does it simplify, more than what does it add and how does it complicate. So it's really reversing the shift of compounding complexity to become simple. So that's our entire vision of the company. So Cinchy itself is a play on the word cinch, which means simple. And that's really what we're all about. So what Cinchy is it's a revolutionary platform that brings data collaboration to the enterprise. It's a radical alternative, and it enables large organizations to avoid having to buy, build, and integrate separate applications. And it enables technology to really deliver on the promise of simplicity. So let's start today with a not so simple subject of who controls the data. So if you think about it for a second, who has control over your data? At a personal level, do you have control over your data? Think about your health records, your financial records. Do you have control over that? Do you know who has access? Can you take that access away if you wanted to? You can sign up for a social network. Makes it really easy to stay connected to your family and friends, but what do you give up in return? How do you actually pay for that? At a professional level, large enterprise organizations, similar question, who has control over the data? Do your customers have control over their data? Do your employees? Your company signs up for a SaaS platform to take advantage of enticing functionality and dramatic cost efficiencies. But again, what do you give up in return for those benefits? The real question isn't who is in control, but actually what. And the answer may surprise you. It is your applications that are actually in control of your data. They entice you with rich functionality and cost efficiencies, but you pay for this privilege with a loss of control of your own data. The more applications you have, the less control you have. And they do this with 3 tricks. The first is that they silo and trap your data across often hundreds of silos. The second is that they make it impossible to properly protect sensitive data and who has access to both see and change it. This is a byproduct of the fact that data is siloed and fragmented, so you have to work around that by performing a really wacky concept called integration, which is another way of saying create copies of data across these databases. And because the general rule is application logic is where you're restricting who can see and change what data, and that's in the application code. In a world where the same piece of data is copied across hundreds of applications, that's hundreds of different sets of code that are attempting to enforce the same rules. It's virtually impossible. It's kind of like trying to protect an airport with every seat on every plane having its own security personnel and its own security procedures. At best, it's the illusion of protection. And finally, they limit your ability to use your own data. So this is beyond even being able to access the data. So if I take a really simple example, let's take an email application. Let's take Outlook. So Outlook is a rich application, has lots of functionalities, just like any other email application, but you cannot do something as simple as send an email to all of your contacts that live in a particular city. And that's one of a million things that you cannot do with the data that you have access to. It's your own email, it's your own contacts, it's your own calendar, but you cannot do that. Your only option would be to get Microsoft to change the code of Outlook for you to work around it by doing it manually, or to install a plugin, which is code that would be written by someone else. Now, you may not care about that particular feature, but that phenomena is a universal truth of every application that ever has and ever will be created. So don't think of applications as enabling you to manage your data and interact with it. They're actually limiting and restricting. They are a barrier. They separate you from your own data. So we don't give up easily. As a defense, we spend half our entire IT budget in most organizations in the world building very complicated integrations, ETLs, APIs, data warehouses, data lakes, master data management, reconciliations, and many more. These are workarounds, and they address only individual symptoms. These are the Tylenols and Advils of the data and application world. Each of these add significant complexity, and they don't end up actually giving you back the control that you actually deserve over your own data. And the result is never-ending, growing, compounding complexity. But so what? If you're familiar with the work of Joseph Tainter, you'll be well aware of the danger of ever-growing complexity. It's been known to cause entire societies to collapse. And I think the real question here is, can the outcome of a collapse ultimately be avoided? Has anyone seen this, this picture before or heard of this work? It's pretty interesting, actually. Check it out if you haven't. For me, I'm actually confident that the answer is yes, we can avoid the collapse, but it does require a fairly substantial shift. If you look back over the past decade, collaboration technology and this new paradigm of collaboration has been proven to be able to dramatically simplify. So the way that we work on documents, the way that we message, the way that we meet, even the way that we deliver projects with the move towards agility as an example, these are dramatically simpler than they used to be not too long ago. But what about data? How do you collaborate on data? And that's really what we're doing with Sinchi as a data collaboration platform, is we're marrying the proven simplification power of collaboration with the incredibly complicated world of data. And that's a very magical combination. And frankly, the impact of those two things together is far more so than the sum of all these others combined. The only way to actually get control back of your data is to separate it from the applications. And that's exactly what data collaboration does. It's the only way for you to get control of your data and enable your customers to have control over their data. But how does it actually work? The secret lies in unlocking the network effects of data. Take the human brain as an example. It manages information as a network. Even logic itself is a function of the data. Let's take an example. So using my phone, I can send a message to each of you, but I do not need to run a wire from my phone to each of yours. That would be ridiculous, of course. But how is that possible? Because in the world of data, that's what you do. These wires are APIs and ETLs. You're literally doing that every time you want to create a connection between two endpoints. So how that works is all of our devices are all connected to something called a network, happens to be the internet. So each of us connect to the network, and that's how we collaborate. And through one connection, I'm in turn connected to millions of other people and systems all over the world. So this concept of networks is not a new concept. Obviously, the internet is a good example of that. But telephone is another example. Power grid is another example. Networks are incredibly powerful to enable true scale and agility. And if you really think about it, data is all connected. It is a network. It doesn't belong inside of an application, but for 40 years, that's exactly how we've architected it. Every app has a database, and that just doesn't make any sense. So what you're seeing, and I'm going to do a live demo in a few minutes and show you how the platform actually works, but what you're seeing is our company's actual data network. So this was just a video of the product taken because we use it for our own company, taken about 3 days ago. Every node represents a data set. The more connected a data set, the larger it appears, the more gravity it has. The different colors represent different domains. Think of them as subnets. So there, for example, is our HR network, but that's just part of a larger network of networks. The platform is designed to run wherever you want. So we happen to run ours in a private cloud, but many of our customers are global tier 1 banks. A lot of sensitive data. They may choose to put it on-prem if they want. But you can follow the data. There's our leads. There's our opportunities. Opportunities can generate order forms, which can generate invoices, which have actual line items for products and services that ultimately end with the provisioning of a license. That's just kind of one example of a slice, but literally all the data about our company is in one location, and it's seamlessly connected and incredibly secure down to the cellular level. So I'm going to show you how that actually works and show you an example of a use case. Because you don't build this in one shot. It happens as a result of accelerating all of your projects. So more to come on that. But how does it work today? So let's say you don't have a data network. How does it work? Well, first of all, there's an app for everything, and every app has a database. And because the data is siloed, you're going to work around it by creating copies of that data through the form of complex integrations, APIs, and don't forget to do reconciliations. So it's going to start to look a little bit more complicated. Also, users cannot interact with the data. They wouldn't know what to do if you gave them access to the database, nor can they interact with code or write code. So you need to build a user experience that allows them to interact with the data. So that's the second workaround that you need to do. Because the data is siloed and duplicated, and as you start to think of consolidated reporting and analytics and AI and ML and all that good stuff, it needs access to consolidated data. It's not going to be feasible for you to go to individual systems to retrieve all that data. So you're going to work around that problem by standing up data marts, data warehouses, data lakes, or more likely, many of each of those things. So when you stand up a new system, it doesn't matter if you're buying it or building it. It doesn't matter if you run it on the cloud or on-prem. The pattern is still the same. You're going to create a new user experience. You're going to have some application that's going to be implemented through code, and you're going to stand up a new database. And you're going to spend more than half of your entire project to wire it up. And that's the pattern that's been repeating itself for 40 years, since Oracle introduced the world to the first relational database back in 1979, beginning the age of distributed systems and the beginning of the end of the age of the mainframe. And we'll come back to that in a few minutes. So if you were able to rewind and recreate this exact outcome, but if you had data collaboration at your disposal, the picture would be dramatically simpler. So instead of having all these applications, instead of having databases, you would have one interconnected network of data where the logic is expressed as data itself, and you still have experiences, but these experiences that you think of today as an application, they don't silo, they don't compartmentalize, they don't write code to implement what you can see and what you can change. It's all expressed as data. So the experiences, and they also don't create a barrier that prevents you from interacting with the data. They help, they give you an alternate path. Think of it as a skin that sits on top of your data, to the point where if you were to add a new solution where you otherwise would have bought, built, and integrated an application, it's now as simple as you're extending the network with additional information, additional access grants, additional rules, and where required, you're adding additional experiences. But what's interesting is while the picture on the right is dramatically simpler, it's far more connected than the picture on the left. The left, to connect to things that don't already have a line, you'd have to build a line. And in a big complex organization, one of those lines can cost $100,000 and take many months. Whereas on the right, everything is connected to each other. The only thing that gets in the way is you need access. So the concept of providing access replaces the concept of providing a copy. So if you go back to the network, so not only through the platform are you able to visualize the network and how all the nodes interconnect, but you can also go into a data set and you can see, and depending on your access level, you can change data. And the data changes can be very simple insert updates and deletes, or more complex business processes that would typically require some complex code. What you're seeing is an example of a skin. Again, think of this as a data experience that sits on top of a data network. In this case, we built these just with HTML, but you can really put any front end on top of that. But the front end doesn't need to implement business logic or rules. It is literally a renderer that makes it easier for you to get to the data. You can always go behind the skin and go direct to the data, and that's where it's still tightly controlled. But what you're seeing is an example of a skin that allows a loan officer in a big bank to be able to review mortgage applications that were submitted online. We also integrated machine learning to predict the probability that that mortgage will end in default, to allow the loan officer to make an informed decision based on a recommendation from the machine. So it's kind of like AI augmentation, but human decisions. But this solution was created including the front-end skin to allow a customer to apply for the mortgage over the course of 3 days, as an example. And it fully works, can scale to have millions of users, and I don't even have to go to the skin. I can go behind the skin, and I can show you how this works when we do the live demo in a minute. But that would be impossible to achieve in conventional technology. This would be many months and probably millions of dollars, depending on your technology approach. But it definitely would not be 3 days with conventional technology. So applying data collaboration, clearly the benefit here is that it can save you a ridiculous amount of time and money. If you look at the average kind of mid to large organization, about 35% of the annual IT spend is on integration. So if your annual IT budget is $1 billion, that's $350 million. But the problem is actually much larger than just integration. And imagine if that was zero, by the way. But think of all the money that's spent on controls, on governance, on buying applications, on building applications. Just think of that complexity. And how in a large organization, if you take a bank as an example, how many of those resources are actually delivering true financial technology versus delivering technology. So what this quickly enables is the entire workforce to align to what the business's core competency is and not have to worry about the mechanics of moving data from A to B and A to C and A to D. So this is a huge transformation. Our entire thesis is that in the future, owners of data will actually be in control. So today, no one personally, professionally has actual control over their data. The architecture just doesn't support that. So our approach from the beginning was, if you kind of buy into that thesis, was to develop the platform that will work in that eventual future, but make it real and applicable today. So this isn't about an overnight transformation, it's about an incremental transformation by intercepting your change projects. And I'll talk more about that in a second when we talk about how to get started. But it works very differently than conventional systems. In this type of a model, owners of data are providing access, they're not providing copies. And that's how it's properly protected. Just like if we're doing document collaboration, instead of me emailing you my presentation, I'm going to put it on, say, a Google Drive, and I'm going to give you access. And maybe my access is that you can see it, or that I allow you to change it, but those changes are tracked. I can roll back. I can prevent you from downloading it. I'm managing the access, and now we can work on it together in real time. We don't have to exchange copies back and forth over email. It's that same concept, but for data instead of documents. On that, all data would be version controlled down at the cell level with configurable workflows. Sometimes different business processes require, for example, booking of a trade needs an approval, but that approval may be conditional on some type of financial threshold. These are the typical rules that you would implement in application code. Being able to define that in the data itself is very powerful because it gives you the opportunity to define those rules once and have them be universally enforced regardless of the access path. Doesn't matter if it's over an API, through a custom skin, through an integrated system, a visualization tool, the rules are now universally enforced. And I mentioned earlier that we're running our own instance for our own company in our own private cloud. But if you really think about having control over your data, you need to have control over where your data is physically stored, be it on-prem, be it in the cloud, so GCP, AWS, Azure, doesn't matter. You have total control in the same way that you have total control over your money. You can take your money, you can put it in your wallet, you can put it under your mattress, you can put it in a safe, you can put it in a bank. And if you put it in a bank, hopefully your bank doesn't just take your money. Otherwise, I wouldn't go back to that bank. But there's controls in place to allow for that. And that's because money has value to you. And if you think about it, data has a lot of value as well. And it should be treated with that same level of respect. So today, you often give up that control. Tomorrow, you are back in control of your data, down to that cellular level. And what I think is actually most interesting about this is the idea of being able to define the rules once and have them be universally enforced. So if you contrast that to the conventional approach, where data, take a typical large organization, maybe they have 3,000 different systems. Maybe 1,000 of those need a copy of customer data. So that's 1,000, pieces of code that are restricting what an individual person, be it a customer or an employee, can see and change. Then add into the fact that that data is then copied into warehouses and data marts and data lakes, and then there's visualization and reporting tools plugged into that are then used by people. Well, how do you implement the rules to restrict what they can see at that layer? It's basically every touch point of data, you're re-implementing the access controls at the same, over and over and over. Just imagine how incredibly inefficient that is at scale versus being able to define that once universally. As an example, all employees can see their own salary, and they can see the salary of everyone who works for them, but they can't see the salary of their peers and their managers. There's an example of a rule, and allowing them to change the salary within a threshold, but only of their direct reports with some type of approval process. That rule itself is expressed as data, and you can define that once and universally enforce it across hundreds of experiences, all your APIs, all your visualization tools, all your reporting tools. They literally can't bypass that because the protection is moved to the data at the cellular level, which is very transformational. So there are millions of use cases for data collaboration, but let's look at a real example. So this happens to be a popular one. So most of our customers, which include large complex organizations, will often have multiple CRMs. Many of them these days will be in the cloud through some type of a SaaS offering. Could be Salesforce, could be Dynamics, could be others. Depending on how the company grew, maybe it was through M&A, maybe they were very siloed, not just in terms of data, but in terms of their business, so they stood up separate instances. And today, everyone's trying to get into advanced and predictive analytics. Maybe they want to get into predicting what the next best offer is for a customer based on that data, but it's impossible to do when your data is all over the place. So with a typical approach, you all have a sense of what you would do, so how does data collaboration change that? Well, first of all, and let's take kind of a hypothetical example where an organization does not already apply data collaboration, and they do not have Sinchi, and they do not have a base data network. So they're starting from scratch. So they would spin up their data network, choose where to put it. They would then configure the built-in connectors. In this case, they would use our Salesforce connector and Dynamics connector, but the platform also has connectors for things like ODBC and on-prem databases, delimited files, anything that's accessible over REST or SOAP, and many others. And the connectors can work bidirectionally. And those connectors can be configured over the course of literally hours, and I'm going to show you this live in a second. And let's say that this organization decided to run it on-prem. So they're standing up their own VMs in their data center, kicking it old school, want to retain protection and ownership of that data. So first of all, what's happened is over the course of a very simple configuration, they've taken back control of the data that was previously trapped in these platforms. It's now under their control. The app's role you can think of as being inverted, where it's now earning its keep by the functionality. It's not trapping the data. It's not creating this paywall that's preventing you from using the data in an unlimited, unrestricted way. So now you have control of that data. Also, you have your internal data that may be from, it could be other sources, other SaaS systems, other alternative, or it could just be legacy systems that are running on-prem. You can now connect that into the network without giving up control. You don't have to release that out the door. You don't have to put it onto a SaaS platform and put it behind yet another paywall. So you've created that network of data of what is required to support the immediate business objective, the actual scope of the project, to enable that outcome. And through the technology and its capabilities, which I'll walk through, you'll see that it shortens the time to market, shortens the complexity and the cost of getting there. But what's also interesting, and maybe even more interesting, is the very next project, which could be a radically different scope. Chances are it's going to need some HR data. It's going to need some customer data. It's going to need maybe some pre-sales activity data. Now, the previous project has paid it forward, and that factor just continuously repeats. Every project will both benefit from data on the network and contribute data onto the network. And in the world now where you're managing access, not copies, it gets very quick to a level where you're doing a lot less integration in a hurry, eventually trending towards what's integration. I don't know what that means. It's all just connected as it should be. So I'm going to show you how it works. So I'm logged into our own instance of Cinchy. So this is our live data network. If I go back to the beginning of time, you can see our network. Do I have a connection? Oh, no. So our network, like all of our customers, starts off really with the Big Bang. These are the built-in Cinchy objects. And then we, just like our customers, we were our first customer actually, will start to apply the technology as an alternative to buying, building, and integrating applications. And the creation of the network is a byproduct of that approach. So as I move forward through time, you're seeing the network is evolving and growing and becoming more and more connected. And if I go back to the present, I think it's pretty safe to say that for us, all of our data is literally on the network. But that didn't happen overnight, so that was over the course of a year. And I can look for any particular piece of data. So for example, I can look for people, and I can see where that data set is, and I can open up that data set, and I can see and even change the data depending on if I have access. So you can see some of these fields are read-only, some of them are editable. That's all driven by data-driven rules. Now, for us, we actually use Sinchi as our CRM. We didn't in the early days, and then we migrated over. We used to also use things like Jira and other things that we've replaced with just pure data collaboration. We now literally run our entire company without any apps. But for demo purposes, we'll mimic our customers' life that have a fragmented system. So let's say we acquired another company that has using legacy technology. So let's say, that, for example, that they're using Salesforce. So what we've done here is we've just stood up a demo environment of Salesforce just to be able to kind of walk through how it actually works. So I'm looking at the list of contacts in a connected Salesforce instance. I'm going to go ahead and add a new contact. So we're going to add a demo person who works for ABC Inc. And I'm just going to populate the email. And that's Mr. Person's email address. Okay, so we've added a contact inside of Salesforce. One thing that I want to highlight is if I click on me as the owner of the creator of this, I'm not looking at my HR record. I'm looking at my Salesforce user account because I'm inside looking at it from the perspective of an application. This isn't the HR system, this is a CRM system. So the natural tendency would have been, if we were to unlearn how things work today, is to expect that that's pointing to my record, my actual person. And that's how it should be, and that's how it works in the context of a data network. But it is a silo, so I cannot run a query and say, give me all the leads that are owned by employees that make more than X amount of money, or that work for me, or that had this performance review, or earned this amount of commissions, because that data doesn't exist in the silo. So if we go back to Sinchi, what we'll see is there's that same contact, demo person, and you can see there's the email address, but notice that it's pulled in some other data somehow. So it's pulled in Bill and Melinda Gates Foundation. It's pulled in that he's a co-chair. So it's pulled in other attributes. Well, how did that work? Let's look at the collaboration log. So what we're seeing is that the record was created inside of Salesforce, but within the same second, we then have integrated another service that through an API enables enrichment of that data based on your email address and pulls in other data. So here we know, for example, that he's a male and he's a co-chair. So that enrichment took place and the resulting data was saved back on the network. We then invoked another API that, based on the LinkedIn profile, determines your personality, and we pulled that in. Then we integrated our own in-house AI to calculate the probability based on other factors that that lead will convert. And based on a threshold that we've defined through data, we've determined that this particular contact is a hot lead, and we have a hot leads team dedicated for that. But also, if I go back into Salesforce, and if I go back to that same record and just refresh it, you'll see, if I go to details, that now, although I didn't type it, the LinkedIn URL is populated here, and it was last modified by Cinchy. So here, what we've done is we've created a configuration of our Salesforce connector enabled bidirectional connectivity. We've taken control over that data. If I had a desire to give access to see or change this data to all of my employees, I don't need a separate license to be able to do that. It's now totally under my realm. And the application is now a slave to the data instead of the other way around. And the data is interconnected because if I'm in here and I click on, say, an account director, it's going to bring me to the HR record as you would expect. It's not going to bring me to my Salesforce user account, which is kind of useless. How are we doing on time? All right. So there's obviously a lot more to the platform. You can create Queries, these queries can be saved and automatically are exposed as both reports and APIs. You can plug in existing visualization tools, which will respect the centrally defined access policies. So I can see all the different networks, I can see all the different tables. So if I want to do a query against our leads data, I can quickly just drag a bunch of columns over. So I've done a select against our leads table, and that leads table, as you've seen, may actually be a combination of data from many sources, some of which may be native on the platform. I can build that query, I can save that query, I can share that query is an API. But one of the things that I like most about it is the fact that I can pull in linked data. So as an example, a lead links to an employee who it's assigned to, and that employee has a manager, because now we're in the HR realm, and managers, like all other employees, have jobs, and jobs tend to be based out of an office location, and an office location tends to be inside of a postal or a zip, which is inside of a state or a province in a country which has a currency. So let's grab the ISO currency code of this particular record. So I'm not doing any joins, I'm just dragging that over. It's what we call a joinless join, and I'm grabbing that field, and that is what would be typically an impossible query, but I can get that data back instantly, and you can see it's getting some values back. And if you think about that, that's data that would be in a reference data system, in an HR system, in a real estate system, in a CRM system, and maybe many of those. But I can interact with that. It doesn't matter. It's on the network in the same way that I can browse the web. I don't care where the servers are residing. I don't care what type, if it's a Windows or Linux box. I'm just accessing HTTP, HTML, and that's it. It just works. As long as I have access, I can do it. And I only need one app called a web browser to be able to do that. Exact same concept here, but for data. And then finally, the ability to create custom experiences on top of that. So I'll just give you one example. So here we built an experience in HTML, and what do they call it, demo person? So what we've done here is just do a kind of a dynamic org chart that allows us to see change. We also pull back the explainability in the AI. I can modify and manage the data here, add tags and whatnot. This is something that we created over the course of a day to enable an experience, but now that experience is unified across not only data originating in Salesforce, but also data that's originating in Sinchi. There could be 22 sources for all we know, and then the experience would work. So the experience is completely decoupled from the data. Those are two separate things. And I can always go direct to the data. So I do want to leave a little bit of time for questions. So we're very excited about this big shift. If you look back, 1951 was the launch of the first commercial mainframe. 1979, talked about that earlier, the launch of the first relational database, the beginning of the end of the age of mainframes, the dawn of distributed systems, the application era. So data collaboration is absolutely the next big shift. And we launched the world's first true data collaboration platform this year. And while we're coming out of our soft launch, it is getting awareness. So we are now on 3 separate hype cycles with Gartner. We were recently selected as a top pick from TechCrunch. So I'll be in San Francisco next week for Disrupt. And actually just yesterday, we were selected as Best in Show at the Finovate conference here in New York. Our customers today include some of the biggest, most complex organizations in the world, and they're using it to avoid buying, building, and integrating dozens of applications and saving millions of dollars along that journey. And they're cutting their project timelines in half, often right out of the gate. So there is an immediate ROI. And perhaps most importantly is they're using it to get control back of their data. We talked a little bit about how to get started. You start at your project that you're going to do anyways. Don't rebuild systems for the sake of it. This isn't a data lake. Don't just dump all your data. That's not the recommended approach. It's intercept your change budget and enable faster delivery, lower risk delivery, and the network then is built out organically as a result of that. So one way to think of it is the network is actually learning from your projects as you deliver real business solutions. And the whole premise of the data model is the user experience forces the network to be grounded in a true representation of how the business actually works. So I know when I look at our network, it's kind of a beautiful design, but there was no designer. It was everyone in the company working together with ownership over their own data. But the end result is it literally is the company, which is quite a fascinating outcome. And you get the benefits that compound over time. And we talked earlier about the fact of compounding complexity and its eventual end in collapse, be it entire societies. The only way to really reverse that is to shift towards a model where we value simplification above all else. So that's what we see this new paradigm of data collaboration doing, is reversing that trend of complexity, and where the world gets a little bit simpler every day with every project. So that's it. So a quick summary, Sinchi allows you to connect all of your existing data together, expand your data network as your business evolves, protect it all with the cellular level protections, and enable your employees, customers, and AI to all collaborate on data in real time. And we have a booth upstairs. We're in aisle 1500, booth P6. So if you want to go deeper, happy to show you how the mortgage solution works or anything else. So please do stop by. And that's it. I'll open it up for any questions.
I'll pass the mic.
Great demo. In our integration world, one
Yeah.
of the complexity that we live is distributed transaction. Do you guys support this? I don't want to talk about distributed
yeah.
transaction because that relates to integration.
Yeah, I get what you're saying though. So the reality is, if you were a company that doesn't have any legacy infrastructure, you could start and end with one platform. But we don't sell to any company like that. We sell to big companies that have the exact opposite problem, where that's going to be a real world problem. So the reality is, just like if you're building a new system, it's going to need to blend into the current ecosystem, and it may need to participate in a distributed transaction. So you can absolutely do that. It does support transactions. And in more complex scenarios, you can always call out to code. So for example, if you want a data change to then trigger other changes in other legacy systems, and it all needs to be atomic, you can do that, but you do that by writing code as an extension into the platform. So you can create what's called a user-defined function inside of Cinchy, and that user-defined function can do anything that you could otherwise do with code. Think of that more as kind of like a dongle that allows you to bridge into the legacy world.
Okay. So it could support integration with event sourcing or approach like that.
Yeah.
Okay.
Yep.
Hi. So I know that you've said that you are defining access at the cellular level.
Yeah.
But putting that aside, it does seem like you're connecting or potentially connecting a lot of different data streams in one place, such that if one skin were compromised, it could potentially provide access to all of the data of a company.
But you're not providing that through the skin. That's the difference. So that's the app paradigm where the skins have logic to restrict what you can see. Whereas here, for example, if I go to, let's go to people, because we went to that table. So if I look at how we've configured the controls, it's not at the skin. The skin has no sense of controls. It's control agnostic. But the controls are at the data layer itself. So here we've defined, for example, Salesforce has the ability to view all the columns, we've enabled it for demo to edit everything, but we didn't have to do that. Whereas we have other systems that are limited down to individual cells of data, but we've also put in certain restrictions to apply kind of a data-driven rule. So if I write a rule here that says, if your name is John and you're more than 22 years old, and the person that you're editing's name is also John, then I'm going to allow you to edit the birthday, but it has to be less than this date. I'm just making up some wacky rule. Is I can define that in the data, and any skin that anyone would ever create, any query, any API, any report, any visualization, visualization is not going to change data, that would be universally enforced. There's no way around it.
So I guess my concern is if someone were able to inject a rule that allowed them to access and edit data through a particular approach, right, then they would have access to your entire set of data. Is that? I guess my question is, have you thought about this? Have you thought about ways to mitigate this as a potential?
Sure, yeah. So the reality is there's nothing in the world that is free of risk. But what I would say is if you contrast the centralization of access policies to the current state is already incredibly uncontrolled. So if you think about it in an organization, there's 500 copies of sensitive customer data. One of them will allow you in, that I can promise you. So today, there is the complete absence of controls. And what we're talking about is enabling the actual enforcement of those controls. Does that mean that everything is foolproof and 100% guaranteed? There's no such guarantees in life. But what I'll tell you is, net, this is far less risky for the same reason why an airport would centralize security, as an example.
We have a few more minutes. Anybody have any other questions?
Thank you. Great demo. Just correct me if I'm wrong that I understood well, but so if you bring the logic into end of the systems, right? I'm thinking of projects where I have been working, and you will have, for example, some resistance of IT keeping, that as you were showing, ERP system or whatever, all transactions are, and when you tell them, well, I'm actually going to put things in there. So 2 questions. One, first, how you deal with that kind of natural resistance you have, and second, and this is where I don't know if I understood well, would that mean that then you need to keep increasing power of the servers because they are going to be doing the computing, and that's sometimes what IT kind of get nervous is you are going to collapse my system.
No, I understand.
Things there. That's why they want to copy somewhere else where it's not production, et cetera, et cetera. So that type of logic, how does that work?
Very good question. So the way to think of it is take conventional technology. If you had a project and that project was going to require you to buy or build an application, there's going to be a contract between the scope of that application and the current infrastructure, right? And that contract could be, it's going to call this API, it's going to invoke the screen, whatever that contract is because you're using Sinchi in that same way to basically deliver on that scope, it's going to meet that same contract. So if the contract with a conventional approach was to leave the origination of a particular type of transaction inside of this current system of record, well, if you're applying Sinchi to that project, you're going to do the same thing. Just because you're using Sinchi doesn't mean you're now going to take control and start to generate all data inside of Sinchi. But every application generates some data, and this can be the system of record instead of standing up another silo. So you're absolutely right, the resistance is going to be there, and frankly, for good reason, because your systems at work, you don't want to introduce change unless there's a benefit. So you want that to be, you want to minimize and rationalize change, right? But at the same time, we know that organizations make a lot of change. And your second question around the computational power, well, first of all, Sinchi is designed to be able to work in a highly regulated environment that has a lot of complexity around volume, like financial services, big banks, massive data sets, large complexity. And while you can do what I would say maybe are simple calculated fields inside of Sinchi that then get persisted for performance reasons, it can also call out to external calc engines for more intensive calculations. So, for example, where we're integrating artificial intelligence, you can either have the model run in an embedded way, but you can also call out to a remote service. So you can use other infrastructure to do the more complicated calculations, but then store the result back on the network. And now that data is available, including the explainability, to all the other use cases. But the computational load isn't centralized.
So unfortunately, we're at time. If you have any more questions, please talk to Dan after the presentation or visit the Sinchi booth. Please thank Dan for a great presentation.
Thank you. Thank you.